Okay, I'm going to do some of the trickier ones here. I might only have time for two, but we'll do this. Okay, the last shall go first. So factors of 1, what is it? 2, 5, and 10. I'll go in there, plus or minus 1, plus or minus 2. So again, if you list all your rational zeros, it would be all of these. So plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And then if I divide by 2, half would add to the mix. So half could be an option 1, 5 halves could be an option. So these are all the things I would try. Okay, so say in class, if we were doing this face to face, we would divvy up the work. Like different people would grab different things. Okay, so say someone grabs a positive 1. Let's see if that works. 2, 2, 6, negative 10. Doesn't look like we're skipping anything. Okay, bring down, multiply, add, multiply, add, multiply, add. Yay, we lucked out. All right, so now, all right, notice this was a cubic, so already we're down at a squared. So I'm not going to keep trying other things, right? You want to go to factoring or something next. All right, so one of my factors is an x. Remember, the factors have the shift. So if the answer is 1, it was x minus 1. Now, do you see how these all have a 2 in common? So there's a greatest common factor. I'm going to pull that 2 out just to make it easier. You don't have to, but it'll make your math easier. So that's x squared. This is 2x plus 5. Okay, now this, I know there's 3 answers. There are 3. There might be 1 real with 2 imaginary. There might be 3 reals. I don't really know. There might be square root ones that are part of the real ones. I don't know. But the option is to have 3 reals, either rational or radicals, or to have, if I have 1 real, imaginary numbers always come in pairs, okay? Kind of like bunnies. They come in, pairs or Noah's Ark or whatever you want to think of. So if you have an I, you have to have a negative I. If you have 4i, you have to have negative 4i. So it could be that these are either going to be radicals over here, like square root of 5 and negative square root of 5, or they're going to be imaginary. So this does not factor. There's no factors of 2 that do that. So I am going to do the quadratic formula. So the opposite of b, plus or minus square root b squared, 2 times 2 is 4, minus 4ac all over 2a. So 2 times 1 is 2. All right, again, it's always a good idea just to type that puppy in a calculator so you don't screw up. Let's see, so what do I have? So let's see, yeah, that was the opposite of b, right? That was a 2, I think, after I factored that out. I hope so. All right, so negative 2 plus or minus, this looks like what, a negative 16 all over 2. So I get, so do you see right now that this could be a radical like square root of 7, and you get negative 2 plus the square root of 7 over 2, negative 2 minus the square root of 7 over 2. But here I can see like, oh my gosh, I am going to get imaginary numbers here, right? So I get negative 2 plus or minus the 16, the 4 comes out, and the I, because this is the square root of 16 times the square root of negative 1, okay? And then I'll divide by 2. And I can simplify because both parts divide. So negative 1 plus or minus 2i. All right. So what are my answers? This is in fact, this is not an answer. That's just a stretch or whatever. So what causes 0? A positive 1. My imaginary, remember, they always come in conjugate pairs. So if I have this guy, I have to have its buddy because imaginary numbers always come in pairs and the front needs to be negative. So the negative's the same. 1 is plus 2i, 1's minus. And I have 3 answers. Now, 2 of them are imaginary, 1's real. Sometimes when you do quadratic formula, because it doesn't factor, you don't get imaginary, but you might get radicals, okay? All right, I'm going to pause, and then I want to do one backwards where I give you all the solutions or the roots or the answers. You have to go back and find the polynomial. So I'm going to pause, and we're going to do that. Okay, so let's look at this one. Polynomial, I know the overall degree is 4, and I'm telling you that you have zeros here. Okay, so notice you only have 3 of them. Now, you might be like, well, maybe this has multiplicity too, it bounces, or maybe this is, no, because remember, imaginary numbers always come 2 at a time, okay? Like Noah's Ark, they come in pairs. So you have 3, and it's the conjugate, so it's 3 minus 2i. The front number stays the same, it's only the middle that changed. Now you can see like, oh yeah, there's 4. So you don't need to worry about multiplicity on this problem, you're good. Okay, now, how do we go backwards? So I want you to find the polynomial, and I want it all multiplied out pretty. These guys are easy. x minus 4, because remember the shift, x minus 5, remember the shift. These are going to be the same way, but you have to be careful because you have to distribute. So x minus the 3 minus the 2i, right? Because technically you're doing x minus the grouping symbol there because you have two parts. Here you don't worry about it, you only have one part, but here you're subtracting all of it. Okay, same thing with this guy. You have x, I'm subtracting all of it. Minus the 3, minus that would make that a positive 2i. You got to opposite both. Again, technically it's x minus that whole quantity. And so then when I distribute it, I get that. Okay, now we have the fun of multiplying this out. Okay, let's do these first, then we're going to do those, and then we'll combine the whole thing. Because order of op with multiplication, you can multiply in any order you want. So getting these together is good. These is probably a good idea. So if you want to do FOIL, you could do first. Outside is a negative 5i, or 5x, sorry, negative 4x, you get negative 9x, positive 20. Again, I kind of like the box for that. So x minus 4, x minus 5, you get what? X squared minus 4x minus 5x and what? Plus 20, and you get that. Okay, this I absolutely love the box. Otherwise, you have to distribute like the x. Distribute, distribute, distribute. Negative 3, distribute, distribute, distribute. Negative 2i, distribute, distribute, distribute. And you're going to have 9 things that you have to simplify. My organizational, my ADHD brain, that does not work, okay? So I need some organizational structure. So instead of a 2 by 2, I am going to make a 3 by 3. All right, so what do I have? I have x minus 3 minus 2i, and then, and again, it doesn't matter which sides. I don't know, I guess I can do this one. It doesn't matter. All right, there we go. Okay, so multiply, I get x squared, negative 3x, negative 2ix, negative 3x, positive 9, I'm just multiplying, positive 6i, 2ix, this is a lot, negative 6i, and a negative 4i squared. Okay, all right, so let's look at what I have. Now, when you take two imaginaries with these polynomials, the reason they come in conjugate pairs is because they should cancel out. So if you do this right, things should go away. So do you see this positive 2ix, negative 2x? That cancels. Do you see the negative 6i and the positive 6i? Cancels. But some of you might be like, but we still have an I. No, we don't. What's I squared? I squared is a negative 1. So this guy, a negative times negative, this is really a positive 4 in that corner. So that's why they have to come in conjugate pairs so that they multiply out. Okay, I get x squared, negative 6x, and I have a 9 and what, a 4, so that's a positive 13. Okay, now if I want this all multiplied out, you're like, oh my gosh, Julie, I have to take that times that. I'm going to get 9 things again. Again, I would not, when I was in high school, I had to distribute and then distribute and distribute because I'd never seen the box. I'm just, when I saw the box, I'm like, oh my gosh, this is beautiful for my brain. My brain needs this. So now I'm going to multiply these guys. X squared negative 9x plus 20. And again, I'll just write it on this side. It really doesn't matter. It's kind of just personal preference when you do that. All right, now I'm going to multiply. Okay, line everything up. X to the fourth, negative 9x cubed. Powers change when you multiply there. Positive, what is that? 20x squared. Negative 6 would be negative 6x cubed. What is that? Positive 54 x squared. That's a 5. Negative 120x, I hope. 13x squared. Oh my gosh, no one told me I was going to take 13. What is it? 13 times 9. All right, let me get our decimals quick. 13 times 9. 117, and that's what? Negative x, and then 13 times 2 is what? 26 with a 0. Okay, and notice we don't have any imaginary because we used our two imaginaries to get rid of those. All right, so it looks like my function is x to the fourth. That's great. What's that? Debt and debt makes more debt. So what is that? Negative 15x cubed. That's cubed. These all go together. So what is that? I should have kept my calculator out. 54, what is it? 67, I think 87. All right, these, what is it? Negative 237, I think, x plus 260. Woo! Okay, so I think I'm okay. Negative 15, that looks right. 67, 87 looks good. Debt and debt makes more debt. That looks good. Yeah. So this polynomial, scooch over, this polynomial function has the answers of this. These are the zeros or the solutions to it. So that's how you can kind of go backwards, okay? Just know that with synthetic division, you want to build all the way down, okay? So if you have something, right, and you do synthetic division and you get a remainder of 0, you want to keep going off, do your next thing that you 0, keep going off the old, okay? Then eventually, like say you keep going off, you have a remainder of 0. Maybe what ends up here is you get, say, x squared minus 7, and you're like, okay, so say you have, I don't know, maybe that's a -1, +3, -4. Okay, so I know that those roots are x plus 1, x minus 3, because again, remainders of 0 mean their roots or solutions or answers. And then my last one is this. Okay, so if I ask for, rationals, -1 is an answer, +3, -4. But there are some irrational. These are not imaginary, they're irrational. Set this equals 0. And again, you might need the quadratic formula. You might, it obviously can't factor, because if it factored, it would be one of the pretty ones, okay? So you're like, oh, shoot, how do I solve this? I would not view it as a quadratic. I would view it as a squaring function. So to isolate a squaring function, you would isolate the squaring part because there's no x here. And then to get rid of squaring, you would square root. Now notice you get 2 answers, plus or minus square root of 7. So my 5 answers are -1, 3, -4, but also square root of 7 and negative square root of 7. Now those aren't imaginary, they're real. It's just I had to, solve for a radical. So when you do this, when you're done, if this isn't pretty, right? Then you're going to need, again, quadratic formula. Maybe you can use, squaring function. But somehow, some way, you got to get all the answers, and you are guaranteed that there's 5. Okay, if it's to the 5th power. Now, again, just know there might be multiplicity. So say I did synthetic division with a -1 twice, right? Like -1 worked twice. Then down here, this would be to the 2nd power, okay? And so when you see -1, that would have a multiplicity of 2. And so I'd have 2, 3, 4, 5, 6 answers, and the overall function here would be to the 6th power. All right. Hopefully that gives you a good overview of kind of how to go about doing these problems. And if you need some additional help, let me know.